Okay. In our previous video lecture, we have discussed that what is the enzyme, what is its characteristics. Now, in this video lecture, I am going to discuss about the activation energy. So, before going to know anything about the activation energy, at first we have to know what is the biochemical reaction. Just because activation energy is directly interconnected with the biochemical reaction. If you don't have any idea regarding the biochemical reaction, then it will become quite tough to understand what is the activation energy. So, first thing is first. At first we have to know what is the biochemical reaction. If you look at this terminology, you can see that this portion is responsible for the biological system and this portion is responsible for the chemical system. Now, at first you have to know what is the chemical reaction. Let's suppose I have a reactant which is denoted as air and we have to convert this reactant into a specific product which is denoted as P. Now, for this conversion, I have given here some amount of external energy. Now, it may be heat energy, it may be force or it may be anything. I have given here some extra amount of external energy and it can be seen that during the time of conversion, the reactant will pass through two stages. The first stage is responsible for the breakdown of bond, and the second stage is responsible for the formation of new bond. This is what about the sense of chemical reaction. So, what is the chemical reaction? In very short, in presence of external energy, if the reactant will convert into a product by breakdown its old bond and by formation a new bond, at the time whole this mechanism or whole this process is known as the chemical reaction. Now, for your better knowledge, you have to know two more things. During the time of its first stage, it will absorb the given energy, and during its second stage, it will release out some extra amount of energy. This is what about the sense of chemical reaction. Now you should know two more things. What is EP and what is ER? Now, whatever may be the substance, it may be reactant, it may be product. Every substance is consist with a minimum amount of mass, and depending upon their mass, they have minimum amount of their internal energy. Now, the internal energy of a product is known as EP. The internal energy of a product is known as the EP, and the internal energy of a reactant is known as the ER. Now, what about the enthalpy? If we talk about the enthalpy is nothing but the per moles energy present. Reaction is known as the enthalpy. Now, how we will find out the value of enthalpy? EP minus ER is the formula to find out the value of enthalpy of a chemical reaction. So, this is what about the sense of chemical reaction. I think this much is sufficient for this chemical reaction. Now, we have to see the types of chemical reaction. Generally, the chemical reaction is divided into two types. Among of them, this type is responsible for the endothermic chemical reaction, and this portion is responsible for the exothermic reaction. So this is the graphical representation of exothermic reaction, and this is the graphical representation for endothermic reaction. Now, let's suppose I have taken a reactant with the internal energy of 10 joule to convert into a specific product. I have taken a reactant to convert into a specific product, but the reactant is consisted with 10 joule of internal energy depending upon its mass. But in case of exothermic reaction, I also have taken a reactant, but in this case, the reactant is consisted with 20 joule of internal energy depending upon its mass. Now I have drawn over here a graphical representation. It is responsible for this endothermic reaction. Now this portion from 0 joule to 10 joule is known as the ER, and the value of ER is 10 joule. Now why I draw this graph from 10 joule? As the internal energy of this reactant is 10 joule, that's why I draw this graph from this 10 joule. Now, if the internal energy of this reactant will be 30 joule, then I have to draw this graph from 30 joule. Depending upon its internal energy, you have to plot this graphical representation. So the value of ER is 10 joule, and the ER is the internal energy of reactant. So this is the value of ER, and whole this portion from 0 joule to 60 joule is known as the threshold energy, and the value of this threshold energy is 60 joule. Now from 10 joule to 60 joule is known as the activation energy. The activation energy. So what is the value of this activation energy? The value of this activation energy is 10, 20, 30, 40, 50 joule. 50 joule. This is the value of activation energy, and this activation energy is responsible for the breakdown of its old bond, or the breakdown of the bond which is present into a reactant. The activation energy is responsible for this. Now you should remember one thing, that threshold energy and the activation energy is not a similar thing. Threshold energy is the summation of activation energy and the energy of a reactant. But if we talk about the activation energy is the energy which is responsible for the breakdown of the bond which is present in the reactant. This is what is the difference between an activation energy and between the threshold energy. And this portion, this 20 joule, 40 to 60 joule is responsible, this 20 joule is responsible for the formation of new bond. Now remaining 40 joule out of this 60 joule is responsible for the remaining 40 joule is known as the EP, or the internal energy of a product. This 40 joule is known as the internal energy of a product. So this is what about the graphical representation of an endothermic chemical reaction. Now if we talk about this exothermic reaction, then you will see that in case of exothermic chemical reaction, the value of ER is 20 joule. That's why I have drawn this graph from this 20 joule. And the value of activation energy is 10, 20, 30, 40 joule. 40 joule. And the value of threshold energy is 60 joule. And the energy which is required to form a new bond is, the bond formation energy is also 10, 20, 30, 40, 50 joule. 50 joule. This 50 joule is necessary for the formation of new bond, and remaining 10 joule is the value of EP. This is the value of EP. Now what we learned from this graphical representation, from this two graphical representation, we have learned that in case of endothermic reaction, the value of EP is always greater than the value of ER. But in case of exothermic reaction, we have learned that the value of EP is always less than the value of ER. Now if we talk about the enthalpy in case of endothermic reaction, then we will see that the value of enthalpy will always positive in case of endothermic reaction. But in case of exothermic reaction, the value of enthalpy will always negative. So this is the basic difference between the exothermic reaction and between the endothermic reaction. Now if both this reaction or a single reaction, think about this, if both this reaction will happen into a biological system, at that time this chemical reaction will be known as the biochemical reaction. Now what is the function of enzyme in a biochemical reaction? When an enzyme will act in a biochemical reaction, at that time it always try to lowering its activation energy. Let's suppose this is the activation energy, before the enzymatic reaction, but when an enzyme come and act on this reactant, the activation energy will go down and the graph will be like this. The activation energy will be go down. Same as in case of exothermic reaction, if an enzyme will come and act on this reaction, at that time it also try to descend the activation energy. That means the function of enzyme in a chemical reaction is to speed up the chemical reaction by lowering its activation energy. This is what about the sense of enzyme in case of activation energy. So what is activation energy? Every biological system is covered by a barrier, and this barrier will protect the chemical reaction to perform in an uncontrolled manner. But the minimum amount of energy which is required to break down this barrier and to perform the chemical reaction is known as the activation energy. But remember one thing, threshold energy and the activation energy is different thing. Threshold energy is the summation of activation energy and the energy of reactant, and the activation energy is the amount of energy which is required to break down this barrier, to proceed this reaction in a controlled manner. And the function of enzyme is to lowering the activation energy to proceed this reaction in a controlled manner. This is what about the activation energy of an